DMVPN Phase 2. In this video, I'm going to talk about DMVPN. Now about the Phase 2 of DMVPN. First, we should understand what is the difference between the Phase 2 of the DMVPN and also Phase 1 of DMVPN. After that, we can configure the DMVPN Phase 2 with a static routing and also with the IGPs. And also here we have some other detail that step by step we will learn about them. This video is so informative because here we are going one step further, and in this video we will learn about the DMVPN with another behavior. Okay, because of that it is so important video and we can use it for better understanding the DMVPN and its functionality. After that, this video also is so important for the DMVPN Phase 3. Also, let me to say that in this class, in the NRC class, we need to know about only DMVPN Phase 1 and Phase 3, okay? Actually, DMVPN Phase 2 is beyond the scope of the NRC, but I'm going to talk about that because it is informative for you. Because of that, this video, okay, is outside the scope of the NRC. All right, now let me to talk about the DMVPN Phase 2. First, let me to review DMVPN Phase 1. You know that in DMVPN Phase 1, when we want to send traffic from one spoke to other spoke, this traffic first should be sent to the hub. For example, assume that we are sending traffic from the Quad 2, okay, to the Quad 3, means from one spoke to the other spoke router. Here we have one spoke router. This is the DMVPN spoke router, or in the NHRP we call it NHC or next hop, or NHRP, NHC next hop client. Okay, this traffic first should be sent to the router 1. Okay, actually it should encapsulate from R2 to the R1. Again, it should encapsulate from R1 to the, for example, R3. Okay, and you saw it. You saw this, for example, function in the previous video. Okay, this is our pass, and this is not so efficient about the routing. In accordance to the suboptimal routing or optimal routing, we need to send traffic directly from the router 2 to router 3 because we have pass. But in the, for example, in DMVPN Phase 1, we have this behavior that the traffic first should be sent to the DMVPN hub or NHS. After that, the traffic can forward it to the router 3. Actually, this is the most important difference between the DMVPN and DMVPN Phase 1 and Phase 2. In the DMVPN Phase 1, we don't need to send the traffic to the, for example, hub router. We can send traffic directly from one spoke to other spoke. Let me to show you. Assume that again we have a traffic with the source of Quad 2 to the Quad 3. Okay, we can send this traffic directly from the router 2 to router 3, and because of that, as you can see, it is more efficient. We don't need to send traffic to the router 1 and then to the router 3. But don't forget, each of these two phase 1 and Phase 2 has some usage. Okay, because of that, we cannot say we are using every time DMVPN Phase 2 or Phase 1. When you want to have more security, maybe the Phase 1 is better because all traffic is going to the router 1. Here we can pass the traffic from one firewall or some other security tools. After that, we can forward them to other spokes. Okay, maybe this is our policy. But in some cases, we don't have any, for example, high security consideration. Because of that, we want to send traffic directly from the route, from one spoke to other spoke. Here we have many design, okay, criteria and many design options that we should learn about them. But for now, let me to say that about the routing and optimal routing, the Phase 2 or DMVPN Phase 2 is more efficient in compare with the DMVPN Phase 1. First, let me to say that what is happening in the DMVPN Phase 2, and then we can talk about the configuration. Until now, we have learned about the behavior of the DMVPN Phase 2, means finally we can send traffic directly, okay, from the router 2 from one spoke to other spoke. Okay, this is the first thing that we should know. Okay, after that, now we should know that how we can create this behavior. Let me to explain it. Again, here we have the NHS, or a next hop resolution protocol next hop server, and also NHC's next hop resolution protocol next hop client. Okay, again, such as the DMVPN phase 1, when we are configuring the router 2 and router 3, okay, here they are registering themselves to the R1. But here in the router 2 and router 3, okay, also we should configure MGRE tunnel. Why? You know that we don't want to send traffic to the NHS or to the DMVPN or to the DMVPN hub. Because of that, we should have MGRE tunnel. You know that MGRE tunnel has only source IP, and destination IP can be anywhere. For example, can be router 1, can be router 3. And you know that here we want to finally have a tunnel from router 2 to router 3. Because of that, we need to use MGRE. Actually, in all of these 3 routers, okay, we are configuring MGRE. We don't have GRE. GRE only is working in the DMVPN phase 1. All right, what is happening? Look at here. Assume that we have configured the router 2 and also router 3. Again, these 2 routers should register their IP address, okay, their public IP address means their NBMA address, and also their tunnel address inside the R1. Let me to show you inside the NHS. We are sending from the router 2 one NHRP registration, okay, message to the router 1. Here we have this information, NBMA address. You have learned about the detail of this information. Only let me to say here we have NBMA address. The NBMA address is 10242. This is the physical address actually, okay? And then we have tunnel address or protocol address or logical address. All of them are correct. Tunnel address is the logical address or the address of tunnel 192.168.123.2. Okay, this is the NHRP registration request. Also, we are receiving NHRP registration reply. Then in the router 2, again, we are sending this information to the router 1. For example, NBMA address is 10343. Okay, and after that, tunnel address is 192.168.123.3. That's it. Now, in the router 1, in NHRP cache, okay, we have this information as you have learned before. With the show IP NHRP, you can monitor this cache, okay, NHRP table or NHRP cache. We have this information. Look at here. First, NBMA address, NBMA or the physical address, and also the tunnel address. Okay, tunnel address is the logical address. Here we have this information. Let me to show you. For example, first 10242, the first NBMA address, and also tunnel address is 192.168.123. For example, 2, then 10343, 192.168.123.3. That's it. Okay, now what is happening? You know that here we have MGRE tunnel. Okay, assume that we are receiving a traffic with the source of quad 2 to destination of the quad 3 inside the router 2. Okay, let me to show you. Here is the real data. Destination is quad 3 and the source is quad 2. Okay, you know that when the router 2 is receiving this update, first it should have one route for the router 3. Assume that in the router 2 we have configured one static route. Look at here. I will explain the detail, but here assume that we have one static route, IP route to the quad 3, quad 255. Okay, let me to configure it here. IP route quad 3, quad 255. The next hop is the 192.168.100 for 123.3. This is the overlay route, static route. Okay, because of that, the R2 know about the overlay next hop. You know that this is our tunnel. This pink tunnel is our tunnel, and the next hop is 192.168.123.3. Let me to write here. This is 192.168.123.3. Okay, the IP address of the tunnel 0. Because of that, we know the next hop, but we don't know the physical address for this logical address. We don't know to which IP address we should encapsulate with the GRE tunnel. Okay, here we should ask from the NHS. Here we have